What is really hidden in the blind spot of the Milky Way? Indeed, there is a mysterious region slumbering around the galactic equator of our home galaxy that blocks our view of the areas behind it and, for decades, embodied the great unknown. But while the so-called zone of avoidance received little attention for a long time, experts have now finally begun to unravel its gripping secrets and realize that a galactic structure of colossal proportions lurks in the blind spot of our home world. Our view of the stars is limited. No matter how much we crane our necks from our earthly vantage point, it's only possible to see a limited section of space. Given that the universe is isotropic, that is, it always presents itself to the observer in the same way regardless of the direction of observation in space, a spherical space arises around the Earth that defines our cosmic field of vision. The observation horizon, that is, the proverbial line of sight, limits that part of the cosmos from which information may have reached us since the Big Bang. Taking into account the expansion of the universe, which has retrospectively extended distances that have already been covered, the distance to the observation horizon is a whopping 46.3 billion light-years. And yet, strictly speaking, it's not necessary to penetrate so deeply into the vastness of the cosmos to realize that space puts natural blinkers on us and prefers to keep some of its secrets to itself. To understand what this means, we have to turn back the wheel of time to the year 1878 and take a look at a book called The Universe of the Stars by a certain Richard Proctor. It contains a large-format illustration showing the distribution of cosmic nebulae. Of course, we now know that these are not nebulae but independent galaxies. However, as an astronomical child of his time, Proctor in the late 19th century was not yet aware of this fact. What the English astronomer did know, however, was that there was a region lying dormant out there that was clearly distinct from all the others. When Proctor used the data collected by John Herschel to create the corresponding image in his book on the universe, he realized that there appeared to be an area of the sky that contained far fewer nebulae than the rest. And so, it was that the author titled the illustration The Zone of Few Nebulae, thus setting the cornerstone for the mystery surrounding one of the most enigmatic areas of the Milky Way. Although the Swedish astronomer Carl Charlier drew attention to this strange area again in 1922, it wasn't until 1961 that Harlow Shapley became the first expert to devote himself to defining this ominous area more precisely. Thanks to the revolutionary findings of Edwin Hubble, it had, of course, long been clear by this time that the supposed nebulae in the cosmos were, in fact, full-fledged galaxies, a circumstance that, incidentally, had also overturned the worldview of Harlow Shapley himself. After all, the American had been one of the most prominent representatives of the camp that continued to see the Milky Way as the only galaxy in the entire universe. But that was in the past. With the help of the latest data from the early 1960s, Shapley found that there are typically 54 galaxies per square degree in the sky. To put that in perspective, a square degree is an area about the size of 5 full moons. And yet, there is a region that breaks the common average pattern of 54 galaxies per square degree, instead containing fewer than 5 galaxies per square degree. Thus, it came about that Proctor's zone of few nebulae eventually became known as the zone of avoidance, simply because astronomers gave that area a wide berth since there was obviously little useful research to be done there. Why is the zone of avoidance problematic for researchers? As briefly mentioned earlier, the zone of avoidance is located at the galactic equator of the Milky Way. But what does that actually mean? Well, to illustrate this, we can imagine our home galaxy as a gigantic disk studded with countless stars. In this case, the galactic equator represents the line that runs around this disk. From our point of view in the solar system, which is located in the outer regions of the galactic disk, we can either look towards the galactic north or south, that is, colloquially, we can look out of the disk upwards or downwards. It is in the nature of things that the view into the heart of the Milky Way contains significantly more structures and objects than the view backwards, or, in other words, into the galactic edge regions. However, what is also in the nature of things is the fact that our home world not only houses twinkling stars but also vast amounts of gas and dust, which combine in the form of cosmic clouds in interstellar space. In fact, the zone of avoidance is also located in the star-filled heart of the galactic disk. Unfortunately, our view of it is literally clouded by the aforementioned gas and dust because they always absorb some of the light. The Milky Way thus acts like a curtain that obscures our view of the areas behind it. Just to be clear, the zone of avoidance obscures about 10 to 20% of the extragalactic sky, and that's the problem, to say the least. How could we get an idea of the big picture if such a large area is left out? To understand the universe, it's essential to look at it on a large scale. For example, our models of the Big Bang predict that even the most massive cosmic structures cannot grow arbitrarily large. But if we find galactic superclusters larger than theoretically allowed, it would mean that our understanding of the universe is incomplete. The same, of course, applies to phenomena and processes that may currently be completely unknown to us. However, the zone of avoidance also appears to be highly problematic on much smaller scales, more precisely, when it comes to our galactic neighborhood. If we don't know which galaxies are still lurking in our backyard, we will never get a complete overview of the development and future of our local group. Despite all these complications, there is still good news. In contrast to the astronomers of previous generations, we are now able to take a look into the zone of avoidance. While it is true that the gas and dust barriers absorb a good portion of visible light, fortunately, infrared light is not so easily stopped. Meanwhile, research into the zone of avoidance is not limited to infrared telescopes, but also makes use of radio telescopes and other methods of non-optical astronomy. Indeed, the investigation of the Milky Way's blind spot has revealed some breathtaking structures, including one of the largest known galactic structures in the entire universe. What is really hidden in the zone of avoidance? The first breakthrough came in 2016 when a team of experts from the University of Western Australia used the Parkes radio telescope to analyze a special spectral line emitted by glowing hydrogen objects to literally see through the Milky Way. Indeed, they were able to catch a glimpse of the previously hidden region of the nearby universe and prove that the zone of avoidance is anything but empty. Quite the opposite, the researchers identified no fewer than 883 galaxies here, around a third of which were completely unknown before. In addition to individual galaxies, 3 galaxy clusters and 2 previously unknown galaxy clusters are also slumbering here. Considering that an average galaxy contains about 100 billion stars, we can imagine the phenomenal mass scales we are dealing with. This discovery was also significant for another reason: it can help us understand what is pulling us. After all, the Great Attractor, a mysterious gravitational center, is lurking out there, which has drawn hundreds of thousands of galaxies under its spell. Our Milky Way is traveling towards this region at a speed of more than 2 million kilometers per hour. And researchers estimate there must be a gravitational equivalent of about 10 quadrillion suns behind it. Though the zone of avoidance is still far from being fully understood, recent research has begun to shrink it. Experts remain optimistic that one day we will completely fill in the blank spaces on our cosmic map.